Hello, Year Nines. The topic of this week is radioactivity, and I'm hoping I'm going to be able to teach it to you via video. So we're going back to about 1910. Marie Curie was working with some materials that interested her because they gave off energy, and she had this idea that they could be used as a source of energy. She was very interested in them. And she won a Nobel Prize in 1910. She discovered radium and polonium, which are both radioactive materials. So she had a couple of tons of ore delivered to her lab, and she processed the whole lot and managed to extract about a teaspoonful of radium, which was how she proved that it existed and won the Nobel Prize. So radium does give off energy. It glows in the dark for a start, so it gives off light energy, and it can give off heat energy. And if it's used properly, that energy can be very useful, but it can also be very dangerous. And she was fascinated with the glow of radium. She kept a little vial by her bed. She ended up dying of radiation poisoning. But she left science a fantastic discovery. So, oh, my dinosaur picture came up. That's all right, it can stay. So radiation has got lots of really good uses. It can be used in the treatment of cancer. You should be writing this down, by the way, uses of radiation. It can be used in medical imaging to view muscles and the insides of your body. Supposed to have the X-ray picture next. There it is. It can be used in X-rays so that you can see inside a body. There's radiation, there's radioactive material, a little bit of americium, I think it's called, in your smoke detectors. It's used to detect smoke. It's used to find the ages of fossils, and we'll talk about that a bit later as well. And it's also can be used to create really clean energy. Now, the energy created by radiation, by radioactive materials, can be very clean, but unfortunately the stuff takes a very, very long time to break down, so there's always leftover waste, and some of that can take hundreds of thousands of years, millions of years to break down, and it needs to be stored somewhere, and that's what makes it, that's the negative side of nuclear energy. All right, radiation can burn. Now, this is sunburn, which is a type of radiation burn. And this is another type of radiation burn from a bomb. And of course, nuclear weapons can be very, very dangerous. So we're going to stop and look at what radiation is and where it comes from. So I'll pause. So I think the first question is, what is radioactivity? And radioactivity, as we know, is energy that comes from the nucleus of an atom. So the nucleus of an atom gives out some energy, and sometimes it's actually some parts of the nucleus, and sometimes it's just some energy. So it goes back to isotopes. I talked to you about isotopes of an element. Let's see if I can draw some. So uranium comes in many, many forms. So uranium's got 92 protons, and it can have a mass number of 234, or you can have uranium with 92 protons and 235 particles altogether in the nucleus, or you can have uranium with 92 protons and 238 particles altogether in the nucleus. So it comes in different isotopes, and like I explained before, when you've got more and more neutrons in the nucleus of an atom, the nucleus can become unstable. So there's a couple of ways that the nucleus can emit radioactivity. In very large atoms with a large nucleus, like uranium, a part of the nucleus can actually break away and go flying out of the atom. So the part of the part that comes out is 2 protons and 2 neutrons. So uranium 92, 234, can lose 2 protons and 2 neutrons to become uranium. Well, it's actually not uranium at all, is it? Because it now has 90 protons and 230 parts altogether, because it's lost 2 protons and 2 neutrons. So it's lost 4 parts. So now in total it has 230 parts. And because its atomic number is now 90, it's lost some protons, it is no longer uranium. It is number 90, which is thorium. So alpha decay is something that happens in large atoms where 2 protons and 2 neutrons come firing out of the nucleus. It's the largest particle that can come out of a nucleus, so it's also the slowest. And because it has 2 protons, which you know have positive charges, it has a charge of +2. So let me just clear that screen up and write all of those things down.